Alright, we're going to be doing the projectile section. I'm going to do quite a few questions in here because it seemed to be the greatest amount of problems that people were having. And it's also, some of them are a lot of the equations that we haven't seen for a while. For number one, you should know that the greatest and most ideal angle for any projectile is going to be 45 degrees. Question number two, we pretty much have a diagram. This is P, the initial location of where we're starting, and then we have our horizontal. It asks you to draw the direction of the vector for the projectile that has a 250 meter per second angle of 60 degrees from the horizontal. So 60 degrees, you should have a protractor measure out 60 degrees, should be about in this direction. So this is 60 degrees. The length for every 1 centimeter is 50 meters per second, so this should be 5 centimeters. And then it asks you to determine the horizontal component of the initial velocity. So you just draw a line straight down, and when you hit the horizontal, you're looking at the component for the speed, which is this here. So you measure it, and you should find to measure it at 2.5 centimeters, which means that the horizontal component is 125 meters per second. Okay. And number four is asks you to explain why the projectile has no acceleration in the horizontal direction. Anytime that an object has left the location and it's in the air, there's no force to push or pull it anymore after it's gone, which means that horizontal velocity is always going to remain the same. Alright, the next question we're going to do is question number 7. Says that how does the magnitude of the horizontal component of the object's velocity at A compare with the magnitude of the horizontal component of the object's velocity at B? Again, because it's the horizontal component, that means it doesn't change at all. So for number 7, everything is going to stay the same. For number 8, it asks how does the magnitude of the vertical component of the object's velocity at point A compare with the magnitude of the vertical component of the object's velocity at point B. Vertically, as you continue to go down, you're always going to be increasing in acceleration due to the acceleration due to gravity. So that means that from A to B, B is going to be faster vertically than A is. And for number 9 on the diagram above, sketch a likely path of the horizontal projected object, assuming that it was subject to air resistance. So that means pretty much if you have your original path, anything that is under the line is going to be considered a probable path, just because you have air resistance. You're not sure what the amount of air resistance is, and it doesn't really matter. Accounting for air resistance means that it will be underneath the ideal line. Okay, question number 10 says that a golf ball is propelled with the initial velocity of 60 meters per second at 37 degrees above the horizontal. The horizontal component of the golf ball's initial velocity is. So if you're looking for the horizontal component without using the scale diagram, all you're doing is using the equation v initial of x, which is your horizontal, equals the initial velocity cosine of theta. So they're given to us that we're looking for v initial of x, the horizontal component. We know v initial is 60 meters per second, and we know the angle above the horizontal is 37 degrees. So cosine of 37 times 60 gives you an x component of 48 meters per second. Question number 11 is the same thing, but it's talking about it in the vertical. So we have a golf ball that's hit with initial velocity of 15 meters per second at an angle of 35 above the horizontal. What is the vertical component? So for the vertical component, you're going to do v initial of y. Now, the one thing is, this is not found on your reference sheet. So I do want you to write that on your reference sheet. The initial sine of theta is going to be your vertical. So We're looking for V initial y. We know that V initial was 15, and then you take the sine of theta, which is sine of 35, and your V initial should be 8.6 meters per second. Alright, we're also going to do question number 12. The one thing that, when you look at number 12, you're looking at this roof that's 50 meters high building, which as somebody kicks off a stone horizontally at a speed of 4 meters per second. When you're looking at the distance like that, and you're considering that it's a projectile that's falling essentially, in this case, pretty much freely, even if the stone is kicked out at 4 meters per second, we can actually ignore the horizontal speed in order to determine the time, because once that is taken into account at a vertical display that goes down the y-axis, that's really what's important. So we don't actually have to account for the x in this case, which means you're going to use distance equals 1/2 at squared. And this equation also is not on your reference sheet, and I told you last time in one of the previous tutorials that you should put this on. So distance is 50 meters, which equals 1/2. Acceleration due to gravity is 9.8, and the time given is unknown in what we're looking for. So 1/2 9.8 gives you 4.9, which equals 50 t squared. Divide each side by 4.9. And you're given 10.2, which equals t squared. Take the square root of each side, and 3.9 equals t. And your units for this should be seconds. Okay, we're going to do question number 22. Question number 22 is also, again, talking about the vertical and horizontal components. So what is the horizontal component of the ball with an initial velocity, which is given at each of those at 8.5 meters per second at an angle of 35 degrees above the horizontal. So we're again going to use the initial of x to find the x component, the initial cosine theta. Initial is 8.5 meters per second, cosine of the horizontal, which is 35, v of x is equal to 6.96 meters per second. Okay, and then question number 23 is asking to find the maximum height reached. So in order to determine the maximum height reached, we're going to have to consider the y component. So we know that the v initial of y is given to us, for the initial velocity, which is going to be over y, is given to us as 4.9 meters per second. We also know that the acceleration, because it's in the y direction, it needs to be accounted for, is 9.8 meters per second squared. And because this is constantly acting on it in the downward direction, we're going to make sure that that's negative. And then we're looking for what is the distance that it traveled. Okay. So if we look at the various equations, we're looking for an equation that will be able to determine its distance based on the variables that we have. The equation you should choose is v final squared equal to v initial squared plus 2a times d. So we do know what v final is, because once the ball stops, because this is a projectile, it's going to be 0. So final velocity is 0 squared, which equals the initial velocity as 4.9 squared plus 2 times negative 9.8 times d, which is what we are looking for. 4.9 squared is 24.01, and we're going to move that over to the opposite side of the equation sign, equal sign, which is going to be negative 24.01, which is equal to 2 times negative 9.8, which is negative 19.6 d. We're going to divide each side by 19.6, and that's going to leave us with 1.23 meters for your distance. Okay, we're going to do question number 33. A plane flying horizontally above the Earth's surface at 100 meters per second drops a crate. The crate strikes the ground 30 seconds later. What is the magnitude of the horizontal component? And so of the crate's velocity just before it strikes the ground. So again, this is horizontal component, so it doesn't matter. It doesn't matter how much time had passed at all. Whatever you had as the initial velocity at time of 5 is the same as the the velocity at time of 50, if it's still in the air. So that means your answer for 33 should be 2. Because it doesn't change, it's always going to stay at 100 meters per second. Alright, we're going to do question number 36, which says the ball is thrown at an angle of 38 degrees to the horizontal. What happens to the magnitude of the ball's vertical acceleration during the total time interval that the ball is in the air? And it's going to stay the same. So no matter what, the acceleration is due to gravity, which is negative 9.8 meters per second squared. So it's going to affect the speed and the velocity, but it's not going to affect the acceleration, because the acceleration will always be the same. And the next question we're going to do is question number 42. A golf ball is hit at an angle of 45 degrees above the horizontal. What is the acceleration of the golf ball at the highest point of the trajectory? Neglect friction. So if we have a parabola, and at the very peak of the parabola, your acceleration, even though it's your acceleration of the golf ball at the very highest point is going to be 9.8 meters per second squared. As gravity doesn't go away. However, the velocity is going to be 0 meters per second. So just be a little careful with that when you're looking at these questions. So this question is saying, what is the acceleration? Acceleration does not change, but the velocity does change, just based on the direction that it's moving against and to and from acceleration. Alright, and the next question we're going to do is none for projectiles. So that's the last question for projectiles. If you have any questions about any of those, make sure you ask during class, or if you want to see another question done, just put it in the post for the Edmodo comments, or you can ask me in class as well.